Hey everyone, welcome to another KieLive. Hey Alex, how are you doing today?
I'm doing great. And how about you, Karina?
Excited, as usual. At every KieLive, I'm always excited, and I'm excited today too, because we're going to talk about rules.
Oh,
Actually,
yes. That's a
DRL,
very good
hardcore.
topic.
Welcome to another KieLive.
Yeah,
Hey
that's
Alex, how
an
are you?
unbelievable topic. It's how I got involved in this community. And this particular topic is how I started contribute to this community. So I
Really?
love, yeah, I back in the days, I think it was 5.3. I helped with the parsing of the DRL. There may have still some code, my code there left behind, whatever. Well, Luca may clarify with us. Oh, I already said who we're gonna be here.
Luca Molteni. So Luca is an Italian guy. I can't help it. It's automatic. I say Italian. I do this. Daniele Zonka always like complains about it, but it is what it is, guys. It is what it is. And he has 15 years of experience as a developer, and he has been working with Red Hat for some of those. And he is a core developer, a core engineer, right at the rules engine. So the guy is the guy to talk about the topic for us today. Shall we bring him to stage?
Absolutely. Welcome, Luca Molteni.
Thank you,
Welcome.
guys. Guys, I
Thank you,
love this
Luca.
introduction. It was so great.
Ciao.
This is not how this is supposed to be used. You should use this when you don't understand something, Karina. So next time you don't understand something, you say, Luca, what is this?
Yeah.
What it is this?
Yes,
What
what the finger is this? You see, what the hand is this? Something like
But
this.
I'm not sure if it's original Italians, but my family is from Italy. A lot of my family, as a lot of Brazilians are my Porcelli. It comes from Italy,
Yes.
right? And all my family talks a lot with hands. So hands is all over the place. May not be doing this, but the hands are all over the place. If we stuck our hands, I think we ended up muted.
Do you do this? Like with this? Or this?
All the hands cannot be stopped.
There's a whole language with using hands, it's been somehow formalized, but it's not that
Once
common.
COVID is over, I'll go there and you can teach me.
Yeah, sure.
So
Can't wait.
Karen is saying hi to everyone, and they are asking, he is asking, how are you today? So send us some love on the chat. Tell us how you are doing today, what you are interested in learning, what are your expectations, and send your questions to Luca Molteni.
Yeah, that's correct.
Yeah, and another interesting thing is Luca has been also involved in a thing that he's not planning to talk, but I will put him in a spot, of course, about the executable model.
Alex, you always do this.
My job.
No, Alex, in fact, I'm going to talk a little bit about the executable model because it was too interesting for me not to talk about it.
That's great. Yeah, executable model is fantastic technology that you put. You are part of that, and we cannot miss this information. This group.
Thank you very much, Alex.
And guys, let me ask something like just to open this session, okay?
Yes.
Can business people write business rules?
That's actually a very good question. I mean, I think they should, but they don't necessarily need to use the DRL. So today we're going to take a look at the DRL, which is one of the ways that you can express the rules, but it's not necessarily the only one. We won't see many of them, but yeah. So can business people write rules? Yes, definitely, and they should. I think that the DRL can be used for them, but we'll see that in the presentation. Okay.
Yeah. And it's also good to keep in mind that we also call DRLs a technical rules, right? So that's one aspect. Technical rule is more close to technical people in general. It's not a rule of thumb, but it's something that we reference technical rule, DRL as a technical rule. What brings a little bit where it fits in the spectrum. So we have DMN. We learn a lot about the different knowledge representation, and DRL is one more to our toolbox, right?
Yeah, that is true. And look, on the last KieLive with Chris Verlainen, we announced the release of Cogito 1.0. And I have a question for you about it, because we have Drools existing for so many years, and DRL is really, really, really powerful today. Will we be able to use DRL also with Cogito? Just so we know what to expect for today, okay?
Oh, that's actually a very good question. By the way, I have a Cogito shirt. Can you see it? I wear it like every day. This is like our uniform in the Cogito development team. No, I'm just kidding.
Every day,
every day. I smell it. I smell. No, I'm just kidding. By the way, what was the question, right? Is DRL supported in Cogito?
Yes.
Again. So,
like in the same way, can you write it in the same way? Will you talk about this during your talk today?
It's a very interesting question. So it would be mostly the same, but we're trying to do some new metaphors. You might have heard already about this concept of rule units. It was somehow introduced in Drools 7, but it was something like an experimental feature. Then we are totally creating a new feature which is somehow similar, somehow inspired to the old rule units, but there are actually new things. And we're trying to create new metaphors for the user to be, more friendly and more hybrid cloud native, which is always the best when using Cogito.
Good, perfect.
But yes, I can confirm that the whole power of Drools will be available in Cogito. We see in the future how.
I love it.
Who's that?
I am.
Okay. Is that your nickname?
No, it's my son.
Oh, it's literally your son.
Yeah, it is.
Hello, son of Alex.
I love it. Like, I just love these lives.
He
I have so much fun.
Today. He won his.
And I have so much fun, and I learn a lot. So I think it's enough of small talk. We should go for the presentation. Okay?
Yes.
Luca, can I share your screen?
Yes, please do.
Porcelli, is there anything else you want to add before we start?
No, but I will make questions on the way, if it's okay, right, Luca?
Yeah, can we?
Perfect.
Awesome.
I have a question. Are we YouTubers now? If your son is watching us, are we definitely YouTubers?
Influencers.
Yeah.
Let's start with a presentation. Welcome.
Oh!
Yes. What?
Please go on.
Something strange happened.
No, it wasn't anything. Yeah, please go on. Don't worry about it.
I heard a shout. Okay, so let me start.
Yes, please.
Whatever. So before starting, let me say a few words about the open source community, because we, the developers of Drools, don't get much feedback about our open source community. I mean, from the customers, we get a lot of feedback, but sometimes we don't just know how you are using our rule engine and what are you doing with it. So I would like to tell you this story. So one day we were just like programming like every day, especially during a pandemic. Every day seems similar. Anyway, comes a user in a Zulip chat and says something like, oh, how can I do this with Drools? And we answered that question. It was really interesting. And after a while, he said something like, okay, so, we're using Drools to send satellites in space. And I was like, okay, really? Are you really sending satellite in space with Drools? And does that work? Yes, it works. Thank you for everything. So what I'm telling you is that people are doing incredible things with Drools, but sometimes you just don't know. It would be so interesting to know about that. Anyway, as I'm showing here, we have the Zulip chat, which is our main channel of chatting. So if you join us on the Drools channel and the Cogito channels, you will find myself, you will find Mario and all the other developers working on Drools directly. And it's really interesting. You can share your experience. You can tell us what do you do with Drools, how can we improve Drools, and something similar. We also have two mailing lists. They are basically dead. No, they're not dead. actually people are using them, but they're just using for technical support. So we receive everyday emails, something like, how can I do this? How can I do that? And it's interesting, and we try to answer every email, but at the same time, we'd love to have some like stories about how you use this. Okay, please, pretty please, we'll be so happy. So let me talk a little bit about the DRL. Today we're taking a look at the DRL. Is an acronym that stands for Drools Rules Language. It's very complicated to pronounce. Let's just stick with the DRL. We won't explain every aspect of a DRL because, to be honest, it's gigantic. There are so many different features. It would take so much time to explain them all, and it would be especially boring. So I'm going to show you only a few concepts to start with our rule engine and to try to understand how this works, okay? And I'm also trying to give you a different perspective. Maybe your perspective is of a user of Drools, and I'm giving you the perspective of engineer working every day, and it might be different. We might learn something from each other, okay? So I'm going to also to show you some tricks about how to debug rules, and something similar. It might be useful for you. And to understand the main theory behind rule engines and behind this Drools rules language, I'm going to compare it to programming language such as Java. I assume that you know Java. I'm sorry if you don't know, but every language is pretty much the same. So, but we must say that the Drools rules language is not actually a general purpose language. Even though I had a discussion with one of my colleagues yesterday saying whether the DRL is actually a general purpose programming language or not, but I don't think it's a general purpose language. I mean, it's Turing complete, so theoretically you could create every program with a DRL, but that doesn't mean that you should, okay? It's always possible, it's always useful to use the best tool for the job. And the best tool for the job, the job that the Drools solves is programming a rule engine, not writing every programming language. So as an example, it's a similar situation to what happened in the database world when the vendors decided to create a specific language to make data extraction from the databases, which is called SQL. Even though we might say that DRL is the specific language of Drools, it's not a common language between rule engine. Okay? So let's start with some theory. Let's start from taking SQL as an example and see the difference between these two flavors of programming, these two different ideas. I would like to introduce you about the idea of declarative programming. It's very different from the style that every programmer uses every day, which is called imperative programming. They're not necessarily better. There isn't one that is better than the other. They solve different problems, and they solve problems in a different way, but they're complementary. They're used together. Okay, so an example of imperative programming, you might already know that, but there is a typical example. Like if I wanted to build a program that builds me a house, if we want to program a robot, what we would do is to ask for the robot to execute a series of steps in order, such as digging a hole, building the foundation, putting each brick in a row to create a wall, and then only at the end to build the roof. When I define a program as a series of steps to be executed in order, I'm creating an imperative program. By the way, imperative comes from the Latin, which means imperare, which means to give orders. Okay, so there is actually a bit of culture here, Latin culture. So an example of imperative.
Loving the culture. Please go on.
Yeah, it's important to know etymology of the word. So an example of imperative programming is Java, the programming language we use to build rows. And let's see the declarative programming instead. We want to create a program to make a pre-built houses. Pre-built houses are pretty common here in Italy, in Europe, more general. I don't know if your country. Anyway, instead of programming a robot to do a series of steps, what I'm going to do is something like to ask from a web service or some kind of service from some pieces, different pieces. I ask for a wall, I ask for a door, I ask for a roof, and I don't really care about the order in which pieces will come. The only thing that I will care is that I need all of them, and at the end when I assemble it, okay? So maybe it's not that typical to order houses via web service, but maybe in the future, we don't know. Anyway, this is called declarative programming. I declare what I need to solve my problem without having to define the steps, the explicit step to solve my problem. And this is a really powerful paradigm. It's of course a different level. And an example of declarative programming is SQL, the one we saw before, or maybe again Java. Java is somehow has some kind of style of declarative programming when you're using the streams API introduced in Java 8. So Java is together procedural, imperative, and declarative. So that's why I said that they are complementary. In Drools, when we use Drools, we don't have control over the order of the execution of our rules. It's the engine that decides for us, okay? Depending on the input data. So when we shipped the first release of Drools, I wasn't here because I joined just 3 years ago. But by the way, when they shipped the first version of Drools, they wanted to ship some programming language to define business rule. And they thought, of course, DRL was a good enough language. But in the end, they came up with so many different ways to define business rules. As we can see here, we have the DRL, we have the executable models. Of course, I put the first one as the most important. No, I'm just kidding. Not because I worked on the executable model, but still we have decision tables, we have DMN models. We're not taking a look at the decision tables and DMN models today, but let me give you a very small introduction about them. Decision tables are a way to define business rule by using some kind of tabular data. Maybe an Excel file or maybe a graphical tool that somehow looks like Excel. And DMN model is a whole new standard to define decisions, which is really, really powerful. It's a super interesting area, and we're evolving that area so much. Anyway, decision tables and DMN models are mostly graphical tools to define business rule. The DRL and the executable model instead is something less graphical, definitely not graphical. It's just code. So if you want to use the DRL or the executable model, you need to know something about how to write source code, and you have to be familiar with the idea of syntax and with the idea of making errors like writing the code. Okay, we use the DRL and the executable model when we want to exploit the full control and exploit the full power of a rule engine. And I think it's very useful. So I saw there was already a question about the business rule. So I assume that you all know what a business rule is, but if somebody joins that doesn't know, let me make a small introduction. A business rule is a concept used to express the business logic of our system. Usually our systems have many, many rules, and each rule is applied to a different subset of our domain. And we've combined all these rules together, we get the whole program. So these business rules are usually written in between the code. So for example, if you program in Java and you have many classes, the business logic might be somewhere in one class and some other parts in another class and something like that. This situation in which the business logic is split among files is really inconvenient to develop big programs. By using a rule engine, what we could do is we aggregate all the knowledge of our system in a single repository, the rule engine. And this will allow us to expose our business logic in a decoupled way for non-technical users, and maybe to evolve it in a different way than a software implementation. I would love to do that. Imagine that you have your business logic of your system in the rule system and you evolve it, and then you have the implementation, then you evolve it, and you don't need to go together. It's very cool. So let's see what a rule looks like, because we talked about business rule, but most of the rule in most of the rule engines look pretty much the same. There is always the when part and the then part. The when part is sometimes called left-hand side, while the then part is sometimes called, right-hand side. The when part defines when the rule will fire, while the then part defines what the actually rule does. The when part in Drools is based on a concept called pattern matching, a mechanism used to see if the input object matches the pattern we provide. A pattern is usually defined as a Java type with 0 or plus conditions. So when an object is inside the working memory of a rule engine and is the same type of a pattern in the when condition, then the rule will fire, will be executed, and the then part will be executed.
Sorry, Luca, but
yes.
I have to interrupt you.
No problem.
Can you help us understanding exactly working memory?
Yes, sure. So the working memory is the idea of internal memory of a rule engine. We see that later, more specifically, when we introduce the concept of our unit of work, which is called the session. But basically, the rule engine is mostly, most of the time, is used as a stateful mechanism. It's something that you can interact with. So you have this area of memory that we call working memory, in which we insert object, we move, we modify objects, we delete objects, and there is this interaction that makes the rule engine really, really powerful.
That's great definition, because that's a very common question for beginners in the Drools, how you put your data inside. So basically, you probably show us a little bit about sessions and a thing, but what do you do when you want to process something? You put explicitly the content that you want to infer inside this memory, right?
Yes, exactly. There are many ways to interact with the working memory. One of the most common, I'll show that later, is to actually insert object into the working memory, into the session. But there are a few others. Don't spoil the presentation. I'll show that later.
Okay, thank you very much. I love that.
Don't worry. I'm just kidding with you. So let's make some example of a business rule, right? So our very first business rule written in Java, you need to insert your first name to sign up to this service. It's a very, very simple Java method called validate. It takes a class that is called input data. It's a DTO that represents what the user is actually inputting. And we use an if statement in Java to check whether the first name with the field of this input data class is null or not. And if it's null, we call this add validation error, calling first name is required. This is a validation rule, as many others, to show, maybe if you are going to sign up to a service, to show an error message to the user, right? This is very simple. It's a very common way to do validation. Not necessarily the most common way. Obviously, you should use Drools, but still, you can do validation like this. It's simple. It's easy to understand. The problem comes when we start to add new validation, of course. Now, imagine to have hundreds or thousands of this rule. We can understand how this simple if-then approach is not as convenient as it seems in the first place. So, for example, in which order should we check for this condition? And what about if we have different conditions? We have nested conditions that depend from each other. And what about if in this method we have to use the business logic in another class? And what about if some developer from our team comes and asks and validate the same input data in a different place? This method can easily become gigantic, and we soon incorporate most of the business logic in our software. And that's not its main problem. There are so many problems. You probably already had something like a class with a gigantic method of thousands of lines. That's the whole business logic. And when you want to understand how your program works, you just have to read this gigantic procedural series of if-then, maybe nested and maybe hidden with some strange comments, something like that. I mean, it's not as convenient as it seemed. Let's try and rewrite this example in Drools and see how it changes. So this is our first example of a rule written in Drools with a DRL. And we see that we have a rule keyword and the name of a rule. And the name of a rule is a string, so that we can write whatever we want inside it. It's really convenient when you want to understand what this rule does. Anyway, this is very simple. We have the when part. The when part has a pattern matching. You see the pattern matching is basically just the name of a class, the Java class, in the when part. And this is the first example of a pattern. You see two things in here. The first thing is a condition. The one that checks is the first name is null. And the second one is a binding that binds a field of the input data to this variable, which is called $u. And this is a variable that we're going to use in the consequence. So the consequence, as I've told before, is the part in the then part, and what happens when the rule will fire. So when the rule will fire, we'll call this validation, which is probably something defined elsewhere, maybe a global variable, something like that. We call the error method in a similar fashion to what we did before. Before we used to call the add validation error method, and here instead we are calling this method on validation. So it's very clear. This is very simple, and it's a good idea to keep our rules as simple as we can get. There's a principle of writing good rules, which is called atomicity. That means that we should create our rules as simple as possible, at the point that they cannot be simplified anymore. Okay? If we have atomic rules, it's easier to reason about this rule. They are self-explanatory. You read this rule and you already understand what they do. If this, okay? This is especially useful when we're dealing with a large amount of rules, and we're going to see this now. So for example, we have multiple validation. In this example, we are validating two different Java types. The first one is input data, and the second one is address data, maybe another DTO of the user inserting his own address. So they're very similar. We are validating whether the first name is null and the address is rule. But as you may notice, we aren't defining here the order in which this rule will be executed. This is very important, and it's due to the declarative nature of DRL. This is a very important feature to handle the complexity when you have a large amount of rules. As I said before, the order of the evaluation of the rules is defined only by the data we provided. And if we can control the order, we don't really need to worry where we write these rules, right? We can write whatever we want, whatever is more convenient to us, it's more important for our business rule. These two rules are atomic and are isolated. If I feed to the engine only the input data, then only the first rule will fire. And if I feed to the engine only the address data, only the second rule will fire. The rule engine, the rules, guarantees that the order of the execution is correct and that it will evaluate our rules in the fastest way possible. This is a great advantage because the algorithm underneath is very, very fast. For example, it makes all kinds of optimization. For example, the example we saw before about nested condition, or maybe the conditions that need to be rechecked many times. The Drools engines handles all of this optimization and guarantees that these optimizations are evaluated in the fastest way possible. And if you think about it, it's really hard to get this right while using procedural imperative language. It's really hard to understand which is the hot code, and maybe you need some profiling to hot path, when you need some profiling to understand which one is the hot path and how we can optimize that. Maybe if there are conditions, it's more logical and more convenient to evaluate one condition before the other. And you simply just don't have to care about if you use Drools. It will be fast, trust me. Do you trust me? Alex, Karina, do you trust me?
With that. I have
What kind of problem?
But one thing that I just want to really understand. So yes. You said that we make some optimizations. It means that if I have that exactly same question more than once, like the condition, name and no in one rule, and using the same object or the type in a different rule, asking for the name null, these will be condensed and be optimized to that. Is this the case?
Yes, there's all kind of optimization. You don't really know how many optimization we put. And the funny thing is that we actually put so many optimization. Even for example, one of the last feature that my colleague is very good is his name is Toshi Yakobayashi. Put an improvement in evaluating constraints on range indexing is really, really interesting. And that guarantees that Drools' engine is getting faster like every day. And I'm telling you.
That's great. Thank you for clarification.
Yeah, no problem. So I'm going to show you some code, because if I manage to write to use my IDE here, just wait a second. And so let me show you some code. Let me share.
You're not sharing the screen. Okay.
I know, no problem.
Okay.
No, I'm sorry.
Oh, Mr. Molteni.
I'm sorry. I was just switching the screen because, you know, these days you have multiple screens. It's really complicated to understand.
I'm here.
Okay, so,
I'm waiting.
Yeah, no problem. Just don't press me. I'm sorry. It's complicated to do this.
No pressure. Okay. No pressure.
Okay, thank you.
Okay.
Okay. Can you see my screen now?
Yes, we can.
Okay.
The idea is to increase your font size.
Yes. Enter presentation. Is it so? Oh no, I see a problem. Just wait another second. I'm sorry. Will be better like this.
Sure.
Let me share a screen again. That's why we have backups. Okay. Okay. This we should work.
See it better now.
That's great. So we're going to create our first Drools project. This is interesting. So we're going to use the Maven mechanism of archetypes. It's very powerful, and of course, we provide an archetype for Drools. And I personally think it's useful to create such small project if you want to play with Drools, with the DRL, and to make some good experiment. There is this key Drools archetype. I'm going to use this version, but you just have to use the final version. And we're going to create this new project, and we call it Drools Simple Project. Let me see. So, okay. And of course, it created the project in the wrong monitor. So we should do like this. Okay. So it created the project, our first Drools project, which you should see. So this project is very simple. And as you can see, it's the simplest as you can get. It only has one dependency, which is called Drools Engine Classic. This is a new dependency that we introduced recently, and it's an aggregated module that aggregates some of different modules. As you can see, I'm not specifying the version in here because we are using the Maven bill of materials, and you should use that also if you want to add new functionality, because in that way you use the correct version. Anyway, so you just, yes.
What version of Drools are we using today in the demo?
We're using 747 snapshot because we found the bug in the very last day.
It's okay, just so we know. So for those who are gonna try this later or just check the presentation, they know what version we are today on December 1st. Actually, we are one after this, right?
Yeah, actually, you should use 747 final.
Okay.
And 747 final should be out today or tomorrow. So please use the final version. As it's not released yet, I'm using the 747 snapshot. I'm sorry. You know, that's the beauty of open source. So, you know, we know where the bugs are. Anyway, so we're using this version, this Drools Engine Classic. This is we call them classic because this is not using the executable model. And but for a simple example like this, it might be a little better. So let's see the structure that has created. So this is a typical Maven project, and you will see in the resource folder, in the main folder, there is this file which is really, really important. It's the K module XML. This K module XML defines it's the beginning of every Drools project. I won't show you this K module XML file because it's really boring. So please check the documentation, but this is important and you need this file. You just need this file to start. Then the archetype will also create a unit test. Cool. And we'll see the test later. And let's see if it works, because it should work. Otherwise, some developers will be, no, it's working, of course. I fixed it. So I'm kidding. So in the main resource folder, you will find some extra folder. This folder needs to be the exact same structure of a typical Java package. And you will find this first DRL. This DRL file contains a simple rule. This simple rule, what it does, it will execute per each measurement having ID color. It's not a great name, but what it does is simply pattern match on this measurement idea when the ID is color. And when the ID color, it will add this, this string color val to this control set, which is basically a global set. Let us see the unit test. So this is the first approach of the key API. The key API is something that has been introduced in Drools, I don't know the version, I'm sorry. I think it's Drools 6. I'm sorry, I've joined this project only for 3 years, so I don't know the whole story. Anyway, this is the API that you use. To start using the key API, use this class, use this key services class that gives you a singleton, which is basically a singleton that will give you every service present in a key API, and we see the structure of how our rules are defined inside the key API. So you have this idea of key container, which is the container for all the packages, and the key container will contain the key bases. The key bases represent the definition of our rules. So just the definition, and every key base will have some package, many packages actually, and with the key base, we can create the session. We briefly introduced the session before. The session is basically our unit of work. And by using the session, you get the key base, which is the definition of a rule, and also the working memory. So by having this session, you can define global variable into the session with this set global method. And then you can start inserting objects, which we call facts. We insert facts into the session. So you see in this unit test, what we do is create measurement, and we insert the measurement into the session. Then we call firewall rules. This is a very, very important, it's probably the most important method of Drools, because it's the method that defines when the rule evaluation starts. And each time we call the firewall rules method, the whole evaluation will start. And of course, in this case, we can call the firewall rules method many times. So I can insert another measurement of the same color with color green and blue. And then in the end, I'll check that our global set will contains the red and the green and blue. So let me show you the DRL again. So what will happen is that I'm going to insert 3 different measurements, and they will both have the color as an ID, so they will match, all of 3 will match. Then we'll just take the second string here and then we'll add it to the control set. Is that clear?
In the second string there is the color itself. Red.
Yes, exactly.
Mm-hmm.
And this is an example. I saw this example many times. So I'm not sure where was it taken. It was in the archetype before I joined Red Hat. But yes, the idea there is a whole series of signals, and the signals has an ID or type. And this is a signal is something like there is this color red, color green, color blue. So it's very simple.
And then on the right side of the rule, can you go there again, please? On the DRL?
Yes, on the DRL, sure. There you are.
On the right side, once you match that value on the memory, once you fire the rules, then it will get this object and add it into a list.
Exactly.
Okay.
Into the global set.
Actually a set.
Yes, but it's the same pretty much. Okay, so these are very simple, and it's important that you learn how to create such very simple project, because sometimes it happens all the time that you find an error with your DRL or maybe a bug in Drools, and you need to provide us what we call a reproducer of your error. And sometimes what the users do is just like open new questions of Stack Overflow, saying something like, I've got this rule and I've got this error, how do I fix it? The problem is that due to the declarative nature of Drools, we cannot know how to fix your rules if you don't provide us the rules. And we can see why it's a big problem, because mostly the business rules are basically the core of your business, and you don't want to share those rules. They are really important to you, and we understand it. But at the same time, if you don't provide us some kind of minimal reproducer, the smallest rule that throws the error, we cannot actually fix it for you. It becomes really, really complicated. Okay, so please, if you're working with Drools Community and you find a bug, it happens. Don't worry, we'll fix it for you. But please provide us a very simple reproducer like this. You create an archetype with Maven and you have the DRL file and just paste it your rules. Obviously, you change it a little bit so that we cannot understand what is your core business. And we don't really care. We just care about the bug. And then we'll fix it for you. Okay? It's a pact. Please do. Okay, so this is the end of my small demo of Drools. Let's go back to our presentation, okay? Okay, just let me share my screen again. Okay, can you see the screen now? Are you there?
Yes,
Alex? Okay, I'm sorry. I'm sorry, guys. So we saw this idea of session, but there are actually two flavors of session. There is this idea of stateful session and stateless session. So I talked briefly with Alex before about this idea of working memory, and this idea of interacting with the rule engine by inserting facts and removing facts is mostly ideas taken from the stateful session, which is the most common way to interact with Drools. Most of our users use a stateful session, but sometimes you might need to have a different behavior. You just don't want the rule engine to be stateful, and you could use the stateless session. Because we show the stateless session later, but let's show a bigger example of Drools before, because now we're getting into the interesting part of a DRL. So we're going to try to define the business rules for an e-commerce system like Amazon, which is pretty famous these days. And we have two different data types, which are the customers and the order. And we've written a unit test to validate the rules of this e-commerce, I'm sorry. So we create a new customer and we create a new order of value 100, I don't know, euros or dollars. And then we insert in the session. So you can see this is a stateful session. And then we call file our rules. As you can see, we also have a category for each customer. The category represents how good of a customer you are. And at the beginning, you are something like a silver customer, so not very good. And if you do just one order of 100 euros, then you'll be still a silver user. But instead, if you do at least a order of 200 euros, and then you insert the fact and file rules, you will become a gold customer, okay? So this might be an example of how you're using Drools. You're using Drools to set the categories for users as something similar. So let's see the rules associated to this. We have a rule that actually does the job. So this rule is called will be promoted to gold when they make an expensive order. So we have a pattern, which is called order, a condition to have an amount of more than 200, and then we set the category of gold. So we have the unit test, we have the rule, everything works fine. This rule is very simple, it's atomic, but it's not necessarily correct. Okay, so it's correct enough to make the unit test pass, but actually it's missing a very big thing. We just don't, I'm sorry, with this rule, the rule engine will know that our customer has become a gold customer. And why is that important? Because when we improve our business rule, and for example, we create a new rule, something like an user will receive an email when it becomes a gold customer. So imagine that you have set an order of 200 euros, and then you want to receive an email, congratulations, you've become a gold customer. So here I've written something like a system out println, but you get the idea. I mean, you're getting an email here. This thing won't work. And the reason why it won't work is that the engine doesn't know that the customer has been promoted to gold. And the reason is that we haven't used this modify statement. This is a really important statement to start with Drools. As I said before, there are many features, but these are the most important feature that you need to know. If you don't know this feature, you won't understand how Drools works. Okay. So what you need to know is actually when you have an order and a customer and you get an order of more than 200 euros, you have to notify somehow the rules engine that this customer has been changed. In this case, we use this special statement called modify, and the modify will take the customer that has been changed and will call the setter to set gold. And this will work because when I call fire rules, this rule will be fired first. And by firing this rule, we will take a look that the customer has placed an order of 200 euros. Then we'll call the consequence, and the consequence will set the category to category gold. And then the rule engine will know that everybody should be notified of this. I'm sorry. I clicked. And then the email was sent. Okay, is this clear? Okay, let's see another interaction of rule. Let's see how we insert facts into the rules. And this is really interesting because, as I said before, we don't have the control over the order of execution of the rules, but at the same time, we can control somehow the order of execution by using these custom control types. So we are seeing here there is a new syntax. We have declare keyword. This is called isGold customer. And with declare keyword, we can create new custom data types. And it's really convenient to create new custom data types inside the DRL because in this way, we don't pollute our domain object that is still clean. Anyway, what we can do is that when a user is promoted to gold, what we do instead is we use the insert keyword to insert a new fact into the working memory. And now you're starting to understand why it's important that this session is used in a stateful flavor, because you can do all this kind of interaction with the rule engine. For example, if we have this idea of an item that is very cheap, and we discover that this item is very cheap, we can start with this rule to classify the item as a low price item. So we can use another custom data type, which is called isLowRangeItem, to insert this new isLowRange item fact inside the working memory. And by doing that, we can create yet another rule that matches when there is a gold customer and then where is a low range item. That sent an email saying something like, please, gold customer, buy this cheap item, because we expect the gold customer will buy all kinds of items, of course. And this is a very useful mechanism to control the order of the rules, but at the same time, to define new behavior without having to change our actual domain objects. What do you think?
And that's great, Luca, because that's one very common problem that we see for beginners. I remember when people are presenting, like this is 2000, early 7, something like that. We're presenting Drools. It was a new thing, and people. But I'm saying these things, and they are not working. Like the modify or the inserted, that's not reacting. And then this is when you show that you need to communicate with the engine, because the engine is not monitoring your facts, right? You need to make sure that you communicate to the engine, and that, oh, now I got it, and that changed completely how you interact with the engine, because now you have a lot of power there.
Yes, exactly. The engine only knows about the fact that you have inserted inside the engine. And unfortunately, if the fact is not inserted in the engine, it cannot just know about what's happening. So please be aware that this is not the only way to control. There are some slight control that you can put inside the rule evaluation, but we won't show it here. This is the purest approach by using these custom data types. Okay?
Okay, thank you.
I'm sorry, Karina, did you have a question?
I just said thank you.
Oh, thank you for this.
Just before just to clarify a question that I have in the chat, one question that I have asked is for your previous example using the archetype where the global set was initialized, or how that happened. And I try to reply in the chat, but if you can show the code where the set is initialized so people understand how the things are connected.
I would love to, but unfortunately, I need to switch the monitors and do another check. What I suggest the user to do is, I'll show you at the end. Okay, so if you can wait a few minutes. But what I'm suggesting you to do is to actually create the archetype. It takes just 30 seconds or maybe 1 minute, and you'll see that in the unit test there will be the first interaction with the actual key session is a method called setGlobal that initializes the set. And of course, it's up to us from the outside to define that method, to initialize that object. Okay? Okay, I'll show that later. I'm sorry, user.
No problem. Thank you.
In a similar fashion, we can also delete facts from the working memory. We do this when there's usually an item that maybe has expired, and there is an expiring date, and of course we don't want the rules to be matched on that object anymore, so we just simply call delete, and the engine will be notified that the object has been deleted. Okay, so this is a basic interaction, defining some rules, some business logic, inserting facts, modifying facts, deleting facts, and something like that. But what happens if we don't understand what's happening? This is typical. This is also typical for me sometimes, even if I'm one of the developers. Sometimes I just write the rules and nothing works. And what do we do? What do the software engineers do? Also, this question gets asked a lot in the mailing list. So I wanted to show you this way. Sometimes you just need to debug in some way what happened. What was the evaluation of the rule? What happened? What rules got fired? And which fact got modified? And which fact got inserted? So if it's not obvious, what do? We could use this class that we provided in the Drools engine, which is called debug rule runtime event listener. So in the session, we put all kinds of different listeners to debug and introspect the session. But there is this one specific that lets you investigate what's happening. And by doing that, we can get something like this, which is a little bit intimidating, but it's really useful if you use Drools for a living, to start and understand how to use these trace. For example, this is the trace taken from the example before. And we have we start from the last thing, which is type insertion. This is the trace line where in the rule engine, we have inserted this customer of category silver. Do you remember that every customer started as a silver category? And then we have, another trace rule saying something like this rule of type modification. So an object in the working memory has been modified. In this example, we have the old object, which was a category silver, always named customer, and this new object, which is customer category gold. And name customer. So this rule name will be promoted to gold. Customer makes an expensive order, has changed this fact from silver to gold. As you can see, it's very valuable tool. It's really important, and I ask you to play with it if you need to have some interaction.
This is how you would debug your rules if you wanted to better understand what is happening during the rules evaluation?
Yeah, sometimes we use this to debug the evaluation of the rules. Of course, as we said before, DRL is declarative. In the rule engine, you don't have the controls on how things are executed, so you cannot really debug it if you don't want to go to the internals of Drools, but you really shouldn't. What you could do is to print a trace of what's happening in the rule engine, and by having that trace, you can understand if something has changed. So what we do sometimes is like we compare two different executions. So we generated the trace for the first version, we generated trace for the second version, and we see what happens. And this is really useful for us to.
I look at this. It looks like the same thing that comes out of the Drools rules metrics module, also created by Toshia, that you already mentioned. And I think it's pretty, like you said, for those who work a lot with Drools, eventually you might see yourself facing these types of logs when you want the deep diver into the engine and tune even more the performance. So
you're definitely right. I should have put something about the Drools metric module. It's a new module. It's been developed something like 6 months ago. It's very new, and it was asked from our customers. And it's really useful if you want to get insight on what's happening in the rule evaluation, how you can improve the rule evaluation. Because I'm telling you, sometimes writing rules is not that easy. It's somehow an art. It's possible to make mistakes. Many of our customers make mistakes, and it happens all the time. And sometimes you can write a rule that is just simply too slow, and maybe they're using some functionality that you shouldn't really use, such as eval. It happens all the time.
And one question that we have in the beginning.
Yes.
Also, I believe it's a very common issue that we have. It's how to avoid loops with business rules, right? Because when you're depending on each other, it's easy to get in the trap that it runs forever. You don't get sense what's going on.
Yes, it happened to me so many times. So the most typical keyword that we use, the most typical functionality you would use to break a loop is to use the no loop keyword. I won't show an example, I'm sorry before, but you can check the documentation about the no loop keyword. Is the easiest way to break an evaluation, a loop evaluation of our rules, but it's not necessarily the best way. What we promote is to actually improve your business model and your business data type, to actually put some very specific field in your data type in order that you can break your loop by yourself by improving your patterns. Maybe if you put in a condition something like, the simplest thing that it comes to my mind, you shouldn't really do that, is something like putting a Boolean flag on the object, but you shouldn't do like this. You should create a new field in your object that for you, it means something. And when it means something, you should improve your rules in order to make the rules just to work on when that condition is true. Was it clear? Did it answer the question?
Totally.
Very clear.
Yeah, great.
I'd like to bring some clarification here. So there are lots of people asking about like how we implement rules in other ways. How do we use Business Central? I'd like to share that this, mentioned on the chat, this session today, unfortunately, we only got like 1 hour to talk about things, and we chose to focus fully on DRL and understand how it works so we can better program with it when we need. But we can totally have another session about about the rules metaphors, like Donato said, on Business Central. Okay.
Absolutely. We are taking notes here, and all the suggestions we bring to our planning.
And they are always welcome. Feel free to continue on doing it. Yeah. So Luca, do you wanna? Luca. Also, yes. Later, yes. I'll need your slides to share with the folks. Sure. And you asked about, not you, Luca, but you at home. You asked about where you can find the slides. I'll share the link with you in the chat, okay?
That is great. Seriously, that is really great. I mean, it's great to have such an interaction with our community, and they're using there. As I said before, there are so many different ways to define rules, and that,
What about rules in the database? Does it make sense for you to have rules in the database? And right, this is a question from the community.
Yeah, this is a very good question, actually.
So, and adding to that, can you update the application, update the rules without restarting the application? So I think these two are connected.
Yes, they're somehow connected. So let's spend a few words here. So the answer is yes. The answer to the second question is yes, of course. There is this idea of incremental compilation in which you can evolve your rule engine, and without restarting the whole system, the whole application, you can improve and modify the defined rules inside rules. But at the same time, we think that maybe the things are changing. For example, we talked a little bit about Cogito before. And in Cogito, if you are using something like a hybrid cloud approach, or maybe a serverless approach, you wouldn't do that. You wouldn't really have a long-running process. So it's interesting for me to see the evolution of these kind of things, because of course, that feature is supported, But we think that the things are kind of changing, and maybe in the future it will be different with the interaction of a rule engine. So maybe in the future, instead of having a single process of a rule engine running and that you have to reboot, and that it takes a long time to reboot, maybe you have many multiple nodes or maybe multiple pods of your rule engine service. And what you would do is something like evolve your keybase, you evolve your rule definition, and then you deploy all these rule definition to all the nodes in your cluster. Does this make sense?
It does, especially because we can architect the application in different ways. So you can either use the engine embedded in your code, or you can also deploy the engine and invoke it like via REST or via JMS. So there are different ways to architect the application in order to make this happen.
Yeah, definitely.
Yeah, and there's one suggestion in the chat. It's about we have a session just for deployment topology that goes towards what Luca is explaining, because especially on the cloud environment that you have this schedule that may kill your pods, like the rely on a session that you change in place is very complicated, because all of a sudden you may not have the same image when the things come up again, the new pod that was killed, move it to a new machine. So that's a very interesting topic that we can cover in a later session.
Alex, take your notes, literally.
Yeah, I am.
Also, another one, this one is good.
Yes.
So if someone wants to try, so in this case, Nick, I don't know how to say your name, I'm sorry, then you can teach me later how to pronounce it properly. But if someone wants to try DRL with Cogito or with JBPM, will there be some limitations on the features in between them beyond the rule units? So what should they pay attention to?
So it's a very good question. So Cogito is a very new project, you have to understand. So let me think a little bit about it. I think we have a question before that we haven't answered yet.
The database one?
Yes, the database one. Let me answer that first. One is in the meanwhile, I think about the best answer to give to the other question. Yes, it's totally doable to put rules into the database, and there are many customers and users of Drools doing that. And yes, the example I showed you before used the DRL inside the DRL file, but of course you can put your rules in whatever place you want. You can put it in the database, you can put it in, but of course, if you put it in the right place, by right place I mean the standard place, you get all a set of features such as auto discovery of the rules. You can get to use the KeyMaven plugin to create kjar, which is a very powerful abstraction in our system. And of course, if you start doing something custom, such as putting rules in the database or maybe generating rules on the fly, because that's very common that most of our users generate rule on the fly, and you don't get to get the good API. You have to do the things all by yourself, basically. So this question comes up a lot. How do I put the rules into the database? The reason, the fact is that we don't have a common API to do that, because everybody does it differently. So unfortunately, when you want to do something custom, you have to maintain it by yourself. That's the answer to the question. So it's totally doable, but there might be some glue code to handle it. Okay?
Yeah, it totally makes sense.
Well, and instead about the question about Cogito, whether we will have limitations in Cogito. So we want to provide most of experience of the rules inside Cogito. But of course, the paradigm, I'm sorry, it's a very complicated word to pronounce. The paradigm has been changed, is changing constantly, and there might be some differences. And we haven't, the reason is we haven't really defined what will be the difference, but expect that there will be eventually some differences. Most of the DRL will be supported. If you take a look at the Cogito examples, I'm sorry, you will find some example of using a DRL in Cogito, but of course, something might be different. I don't know if this answers your question enough. And
yeah, sure.
This may be some topic that I should better discuss in a mailing list. There is a Cogito mailing list. I'm sorry I haven't put the Cogito mailing list inside the community. I should have, now that I think about it. And it's a really interesting topic. And please send an email in the Cogito mailing list and we'll discuss about it. Okay?
Or just join the Zulip chat and we can discuss it too, right?
Yes, we are here every day, every night.
Every day, every night, always. So we are at the top of the hour. Would you like to wrap up your presentation?
Yeah, sure. I wanted to show you something interesting about the executable model, but let me let me say that it's fast. It's super fast. The executable model is something that we invented to have very fast startup times. It's the core technology we use in Cogito, and it's really important. So please take a look at the documentation or send us an email in the community or write us on the Zulip chat. If you want to discuss the executable model, there is always me, Mario, Toshiya, and all the other guys working on it, and it will be fun. Okay? I think that's it. Let me stop sharing my screen.
Okay. Awesome.
It was very, very interesting. Thank you. Thank you for doing this, really.
Yeah, and I think this interaction, all the questions, that's one of the key aspects of this live, right? So people from our communities can interact and make these questions. Sometimes we go a little bit over time, that's today, but it's completely fine because we are interacting. That's the purpose of doing that.
Yes, definitely.
Totally. Luca, I'd like to thank you for your time, for this great presentation. I won't put you on the spotlight, but I'll contact you on the backstage to see if we can schedule more cool sessions like this about the rules engine. Sure. And please remember to send me the slides so I can share with the folks on our repo. If you are watching us right now, all our slides are available here on this GitHub link. Since day one, okay? And yes, please go on.
Day one.
Day one, yes, day one.
Day one.
And I think that's it, Percelli.
Yeah, thank you very much, Luca, for great presentation. And likely we'll have you back here to go deeper in some topics. I have at least 5 different suggestions of different topics that we can cover deeply in different areas. That's fantastic.
Yeah, thank you again.
Great. It was great to be with you here today, Percelli, Luca, Statis, Paolo, Vinayak, everyone there, Danielle. I just love having you live with us, sharing knowledge, because that's what matters. So, Luca, you like etymology. What does key mean?
Oh, that's a good question. I don't know. No, I'm just kidding. No, I'm just kidding. It stands for knowledge is everything.
Great. Thank you.
Did I win a prize?
Unfortunately not.
It was supposed to be an owl somewhere, the owl of Cogito. We have our owl. Oh, there it is. Yeah. Oh, it's the owl of Key now, I remember.
Yeah.
Yes.
The Cogito, yeah, you're right, is the Viking, of course.
Yeah.
Thank you, everyone. Have a great week and see you next week. Bye-bye.
Bye.
Thank you very much.